Okay, class, hello. In this video, I'll be discussing about um, angular kinematics. Okay, sige. So I hope you've already read your um, textbook, no, our main reference on angular motion. So angular motion, this is another term for rotation. In the first set of my lecture videos, I discussed about an important point in any system or any object, which we call the center of mass. So in this lecture series, I'll be focusing on um, the description of the rotation. No? So this is angular motion, and then we'll just focus on kinematics. So if you see in the figures here, we have here, I also use this image as um, an introductory photo in the PowerPoint for angular motion. No? So you notice here the pattern of the water molecules that come out from, or that moves away from the diver here as he does the the somersault, for example. So you notice the pattern, it's somewhat circular, no? Ayan. So the diver here, as he rotates, it's his center of mass will also tell us that it's as if the diver is just a particle, because the center of mass of the diver here will project a motion of a particle. However, as we discuss later, no, the effect of force in rotating an object. Say, for example, when we talk about torque later, we can no longer use the particle model. Okay, so we'll be using the extended model na, the concept of rigid bodies. These are examples here of common, of usual objects that we know, no, that are we are familiar with, no, yung mga objects na umiikot. Say, for example, itong bolt dito, it can be rotated using this wrench here, no? So the torque of the force of the hand here will cause this bolt to rotate. Dito naman, meron kang axle dito and then tied by a rope. We'll go back to the two systems similar to this when we go to rotational kinetic energy. And then, ito ngayon ang gagamitin ko, itong bicycle wheel, for example, in describing the kinematics of the rotational motion. But first, let's establish muna the range of validity, no? So, ano ba yung limit lang ng pag-aaralan nating kinematics? The limit would be, okay, so klaro naman, di ba, na rigid bodies ito. So, if you recall, I've already mentioned this in the previous video. Pag sinabi mong rigid bodies, okay, size and shape does not change. Size and shape, okay, are constant as they undergo motion. As they move, no? Pag nagro-rotate sila while undergoing motion. And then the second one would be, there's this what we call axis of rotation. So an axis of rotation, okay, is an imaginary line, okay? It's an imaginary line that cuts through the plane where the rotation is going on, and it connects all the centers of rotation of all the particles in the system. So what am I talking about here? Okay. Now, axis of rotation, ito for example, as this wheel rotates, let's say nag-rotate siya counterclockwise. Pero hindi natin siya bibigyan ng translational motion. Okay? So if you remember, pag sinabing translational motion, okay, I hope you've read about this. So pag sinabing translational, lahat ang orientation ng object mo hindi nagbabago. It's just the whole body, either it goes horizontally, so pwedeng ang object mo is moving horizontally like that, going there, Or pwede namang it's just moving vertically pero not rotating ito. Or pwede namang two-dimensional. So kung nag-projectile siya, for example, ayan. So ito, these are examples of translational motion, purely translational. Kasi yung object mo hindi umiikot, okay, habang gumagalaw. Now, ang pag-aaralan muna natin is purely rotational. So, as the word itself tells, rotational, the object is rotating. Pero kung purely rotational, walang translational. So, it's either itong wheel na ito, let's say merong mechanism na hindi siya makagalaw forward or backward, kundi ikot lang, steady lang siya, edi sa rotational, yung orientation ng object mo nagbabago, pero wala siyang change in translation. So ito, for example, pwede siyang umikot na ganyan. Okay? Later, pag ito na dito, ito, constant pa rin pala yan. So let's say, for example, yo-yo. So si yo-yo, di ba, merong time na iikot siya, and then itong axis of rotation niya, pwedeng magbago din, andito na ngayon. Okay? Sa case ng yo-yo, meron siyang rotational habang umiikot siyang ganyan, meron din siyang translational. So this is an example of combination ng translational and rotational. In the first part of our study here, we will only focus on rotational. Kasi tapos na tayo sa translational, di ba? So dito muna tayo. Later this week, we will go to combination ng translation at saka rotation. Okay, I hope klaro na yan. So let's go back to the concept of axis of rotation. Again, it's an imaginary line that cuts through the plane where the rotation happens. So for example, itong si bike natin dito, kung ang pag-ikot niya ngayon, nakaswipe siya ngayon ng circular path na nasa x-axis. So, for example, ayan. Let's say, symmetric man yung itong tire natin dito. So, ang center of mass niya is somewhere here. Ayan, center of mass yan. This is the x-axis and this is the y. Walang translational motion yung object natin. So, itong center of mass, hindi mag-change position sa x, hindi rin mag-change position sa y. Diyan lang talaga siya kasi gusto nating ang axis of rotation, static lang muna tayo. Hindi natin siya pagagalawin. Okay. So, itong si axis of rotation, kung nasa XY nangyayari ang rotation mo, ang circular motion ng object, ang axis of rotation is nasa pangatlong axis. So, dito siya ngayon sa Z-axis or Z. So, meron ngayong Z-axis dyan. That's 90 degrees. 90 degrees yan. 90 degrees yan. Okay? So, this is now the Z-axis. Now, kung pipili tayo ng, let's say, 3 point sa bicycle natin, let's say, meron akong point A dito. I'll call it point A. Another point somewhere here, point B. And then another point closest to the center, point C here. Ayan. So, kung yung as the tire rotates now, pag tuyok anang ligid, dili na to pa abantehon or atras abante ha, pag-ikot ng tire natin dito, natural, lahat ng point masses na member ng buong tire, they will also move in a circular manner. Hindi pwedeng nakaikot na si A, tapos si C nag-steady lang, or si B na una. Meron silang iisang frequency, no? Merong iisang angular frequency na isa-isahin natin mamaya. So, kung i-focus natin ngayon si A ngayon, from here, going to here, so ito yung circular path, na iikutin ni A habang nakasakay siya kay wheel. Ayan. Ang center of motion ni A, ito. Ayan. Itong si B, na ang radius din is ito, then iikot si B, yan, ikot siya. Ito yung circle na nadadaanan niya, mas maliit kaysa kay A. Pero ang center ni B, ito pa rin. And the same is true for C. Itong circle ni C, so concentric circles ito, meaning all of the point masses that belong to this rigid body, ang rigid body natin is yung buong tire. Meron siyang countless n particles kasi extended object yan. So it's a continuous system. Okay? Kung pwedeng ganyan. Pero nag-identify lang tayo ng tatlo para hindi tayo mahirapan sa discussion natin. So, itong concentric circles na ito, ayan, dito yung centers nila lahat. The axis of rotation now is an imaginary line that is 90 degrees with this plane where the rotation happens, okay? And it cuts through all the centers of rotation. Okay? So, meaning, si axis natin, axis of rotation, will always be in the z-axis sa ating discussion. Nasa z-axis tayo for axis of rotation because we will always let the rotation to happen on the xy plane. So, rotation on xy plane, and then our axis of rotation is nasa z-axis. Okay, ayan. Kaya, sa kinematics natin mamaya, meron tayo always subscript na z ilalagay to remind us that the axis of rotation ng pinag-aaralan natin is along the z-axis or the z-axis. Okay, I hope that is clear now. So again, let me repeat. Axis of rotation is an imaginary line that cuts through the plane where the rotation happens, and it passes through all the centers of rotation of all the points that belong to the rigid body. Okay? Klaro ba? So, sa first natin na limit ng discussion natin ng kinematics, we will set that, okay, let axis of rotation be constant muna, be stationary muna. So, let axis of rotation be stationary. Hindi muna natin siya pagagalawin. Meaning, walang translational. Rotational lang talaga lahat. Okay. Stationary or static or at rest. Okay, or at rest. So, later na muna yung gumagalaw siya. Okay? I hope that settles it. Now, let's go to the kinematics itself. Okay. I'm still presenting. Ayan. I'm just checking. Okay. Is my microphone on? What the heck? Tama. Sorry. Ay, guys. Pardon my mouth, guys, ha. Sensya. Okay. Let's continue. So, let's talk about, ano na naman natin to. I-borrow ko muna itong picture na ito. I-duplicate ulit natin sa, yan, here. Ay, bakit? Erase ko muna, guys, ha. Okay, I want to use this. Oops, erase. Okay, and then let me move this there. So, let's talk about the kinematics here. Oops, saan naman to siya? Pihan ko muna, ha. Gamay man. Wait. Oops, ayan. Oy! Sorry. Intermission. Ayan natin. Nasyado. Okay, that's it. Ayan. So, dito tayo sa wheel natin. Ayan. So, the rotation happens on the XY plane, and then we have the axis of rotation in the Z that is stationary. So, let's identify one point only. Let's say ito si point A. Okay? Or point O na lang. Ayan. So, si point O. Now, let's say si point O is somewhere here pag-start ng timer mo. So, let's say when time is, initial 0. Now, I will have to write now the reference natin for our rotation. We are now into kinematics, meaning i-describe natin yung motion ng rotation natin. Now, okay. So, if we connect now, ito si O, from the origin here, where the axis of rotation passes through, yan, may axis of rotation yan, Z, this is X and this is Y. Okay. Now, as the object now rotates, so ito may R, ito ngayon yung R ng rotation ni O, ha? Okay. So, it makes an angle here, from here to here. Tawagin natin tong angular position, theta sub 0. So, I'm now starting kinematics. We now talk about angular position. Okay, angular position. Okay, symbol natin for angular kinematics, lahat Greek letters. So, ito tawagin nating theta for angular position. Okay, now, from the word itself, position, it's a location with respect to a certain reference. Kaya lang dito ngayon, it's angular. So, by angle na ito. So, looking at this, we say that, let's say, umikot yung wheel natin pa counterclockwise. Yan yung angular velocity niya. Mamaya na yan. Let's say umikot siya. So, after some time, itong si O na dati-rati andito, let's say andito na siya ngayon. At a later time T. Later time T. So, yan pa rin siya. Si point O yan. Okay, nasa na yun? Okay, this is still point O. So, the reference natin is the positive X, guys, and then we go counterclockwise. So, the final angular position now is galing ka sa positive X until dyan ngayon, sa phasor na yan, and then we'll call this as the final angular position. So, in other words, angular position here is just somewhat similar to translational position that we learned earlier. Translational, translational position. Kung nasa x-axis, x ang tawag natin. So if you recall, sa translational position, if this is the x and this is the y, kung ito yung origin, kung andito yung particle mo when time is 0, then we know that this is the initial position. Translational ito, x sub 0, di ba? Kung after some time, nandito na siya, with respect to a certain reference, ito man ang reference natin. Ito yung later time t. So, ang final position niya ngayon, start sa reference until here, that's the final position. And then, if you recall, kung kukunin mo ang difference nito ng final at saka ng initial, this is your your displacement, which is x sub 2 minus x sub 1. Diba? In this case, this is 1 and 2 na lang for consistency. Ayan. So, parang ganun din dito. Kaya lang, instead of translation, pa-angle, pa-ikot, pa-angular position siya. Okay? So, ang reference natin is positive x and then you go counterclockwise. Tapos, it's measured as an angle. Kaya, ito, kung si translational position na ka-meter, ito, ang unit natin, radian. Okay? Rad na yan. Unit is radian, which is also rad, which is physically an absence of a unit na binigyan na ng pangalan. So, what am I talking about? So, if balik tayo dito ngayon, so, ito ngayon, ito yung na-sweep na angle ng point natin. Okay? So, arc pala arc. Ayan. So, diba S yan. So, if you recall your trigonometry, theta, okay, ito, in this case, theta sub naught ang tinawag natin. Pero in general, let's say theta is equivalent to the arc length, okay? The arc length here subtends the certain angle theta. Again, divided by the radius. So, ito man yung radius natin, di ba? R. Ayan, R. So, si angular position natin, yung angle, is really wala siyang unit. Kasi kung naka-meter si arc length, naka-meter din si radius, walang unit yan. Yung kawalan ng unit, tinawag na radian. Okay? Para lang may pangalan talaga. Pero si ito, wala talagang angle yan. Okay? So, in other words, we say that theta sub naught is initial angular position. Or pwedeng 1 na lang siguro para consistent tayo. Ayan, 1. And then si theta 2, that's final angular position. Angular. And this is final angular position. So that, pag kinuha natin ang difference ng theta 2 minus theta 1, ito yung angle na makukuha natin. Ito, from here going here, this is now the delta theta. Okay? So, angular, tawag nito, change in angular position, we call it angular displacement. So, in other words, final angular position minus initial angular position will give you angular displacement. Okay, take note of that. So, delta theta, this is angular displacement. Okay, kailangan talaga sabihin mo yung qualifier na angular. Pag translational, hindi na natin sinasabi ang word na translational. It's simply position, displacement, etc. Okay, angular displacement. And then the MKS unit is radian. Ayan. Okay, now balik tayo. I hope you're still with me. So, alam na natin ngayon paano mag-describe ng angular position, no? Ayan. And dito muna tayo. So, if you recall, if the arc length is equivalent to the radius, then that is the value of 1 rad. So, if we have theta ngayon, kung pareho ito sila, equal sila, then theta becomes 1 radian. Ayan. Take note of that. And then this is just equivalent to 57.3 degrees, if I'm not mistaken. So for our unit conversion factors natin, kasi dapat, pag nag-work na kayo ng problems later, conversion fraction, so daw. Pag nag-solve na kayo later, dapat lahat ng angular position, lahat ng angular displacement naka-radian. So, we say that in one complete revolution, so one revolution, that would be 360 kung degrees ang unit mo. And then kung rad naman, that's 2 pi rad. And then from this, you can generate other conversion factors. So say for example, kung kalahati lang yung gusto mo, 1/2 revolution. So kalahating revolution, that would just be 180 degrees, and that is just pi rad. So if there is a given ng angular position na naka, let's say, sinabing 50 degrees si theta, edi convert natin siya to radian kagad. So pwedeng kang magbuo, let's say 360 degrees, and then meron kang 2 pi rad. Yan. And then makancel mo na si degrees, and then ang unit mo ngayon dito, naka-rad na yan. So do not forget. Okay? You can also, if you know the angular position, and you know the radius, then you can get the arc length and vice versa. It's just a simple conversion, no? So, pwedeng ito, and then sabihin na if the arc length is, let's say, 0.30 meters, what must be the radius of the path? O, ayan lang. So, pwede mo lang sabihin na theta is equal to, I don't know how to pause. Oh gosh, wait. Dili pwede na ako i-pause. I cannot pause this. Pangutanan na lang sa si Dadabi Consenso. Hindi na ako ma-pause kay Google na eh. Okay, sorry for the interruption. Ayan. So, where was I? Ayan. So, kung yon, theta, then you just say theta is S over R. And then theta S, I'm sorry. Ayan, nawala na ako sa focus. Kaya nawala ko. Sorry. So, we're looking for the arc length, the radius. Tama. So, the radius is just S over theta. So you have 0.3 divided by, yung answer natin dito na rad, ha? Dapat naka-rad yan. So that, ang unit dito na meter, yun na yung answer mo din dito for the radius. Okay? Ayan. Sige. Now, okay. Intermission number ka ito. Ayan. So, where was I? That's angular position. Okay? So, I'll stop muna here. Baka medyo mahaba na itong video na ito. I'll continue with angular velocity and angular acceleration in the next videos. Okay? Ayan. So, let me stop this first. Okay. Stop recording. Okay.